Okay, so I'm going to talk about asymptotes, more on asymptotes if you already understand them. And so we'll do a problem in which we will have stuff on top of a rational polynomial. What's a rational polynomial before we get far ahead of ourselves? Um, let's see. Let's go into Maple and write that out. But for those of you who already understand what a rational polynomial is, we will continue, and then we'll go back and explain that real quick. Yeah. Rational function, I didn't mean rational polynomial. Rational function is a function which you have a polynomial above and a polynomial below. So let's go in here. Alright, blah blah blah. This is kind of a lot. So anyway, I'm pulling up Maple. Maple's this interesting program. And say if we have, okay, so a rational function is just where, say, like if I have some polynomial, okay, say x squared plus 3 plus 3x plus 2 or something. Divide that whole thing, not just 2, but the whole thing, this whole polynomial. Control Z. Okay, why did we do that? Okay. By some other polynomial, x plus 1. Okay. This is a rational function. Okay. So let's go into our graphing calculator. Okay, so I want to do a specific example. Let's do, let's say x minus, let's try this, x minus 2 times x plus 2 divided by x, and I do double parentheses because I want the graphing calculator to know that this whole thing right here is in the bottom. So let's graph it. See what we get. Now if you can see what's going on here, let's go back and write that in. So what do we have? X minus 2 times x plus 2. Alright. Should have x minus 3 times x plus 3. Okay. So, alright. What's going on here? Well, okay, so anything on the top, you should understand, is not going to give us an asymptote. Only the factors at the bottom. So we should have an asymptote at -3, which we do. We also have another one at -3. Now, another thing to note here is that, okay, ask yourself, how many different factors do we have in this whole expression? We have 1, 2, 3, 4. Okay, so imagine if all those were negative. So if you have all these less than a certain amount, so you know, if you go out to a certain part here, out here, and these are all negative, well, you have a negative times a negative over a negative times a negative. Well, if you have 4 negatives, you know, you're going to end up with, you know, 4 negatives, whether divided or multiplied, is going to be positive. So, as you know, after you get past -3 right here is going to be positive. So we're going positive, 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 positive until we get to 3, and we go to infinity, and then after that point we're negative, coming back up. Now, as soon as we get to close to -2, well, now we're positive. Anyway, essentially what's going to happen is it's going to alternate, right? And in every graph you're going to do this, because once you get between one guy, you know, once you get to, you know, past a certain value, so like the whole graph is going to be positive at a certain point, And then once you get past a certain point, then one of these guys, this factor is going to push out something negative, right? And then as soon as you get close enough, now you get to 2, negative 2, then both these guys are going to give you both something, both something positive. So after that point, you have 2 positives, and you're left with 2 negatives. When you're done, after that, then you're positive until you hit the next guy. And so it's going to do that the whole time. Now, what if I had, let's just throw in another guy in there, just to be fun. Say like x plus 1. Okay, and let's do it on top for a half second. Let's go. So let's say x plus 1, and let's graph that. In fact, I'm debating on, well, it's going to give us another graph, so maybe I'm just going to graph it, and I'll copy that. Just might be a little bit confusing. But anyway, now this guy is going to, not only does it give us a slant graph, because multiply this out, you have a polynomial of higher degree than this, and it would be 1 degree higher. So you're going to end up with a certain ratio of, you're going to end up with like, whatever it is, like 3x cubed or something over x squared. In fact, if you just have x's right here, you're always going to get x cubed as your highest whatever it is, however number of x's on the top. I mean just x's by themselves, right? If I had 2x or something, then this wouldn't hold. But you have just x's right here, and that would end up with x cubed, x cubed plus something plus something plus something. And on the bottom you have x squared plus something, plus whatever it is. Well, actually minus 9. So anyway, in this case, what happens is it's pretty much the same thing, except for now we're going to actually have the graph cross more than one point before it goes back down. It actually crosses here at -2, then again at -1, and then back again at 2. And again, it still follows the same rule. We're negative. Instead, now we have 5. So now we have 5 guys. Okay, we have 5 different 1, 2, 3, 4, 5. We have 5 different factors. Okay, so when we're far away to the left end, we're going to have a negative value, right? Because 5 negatives multiplied and divided is going to give you a negative, right? An odd amount of negatives is going to give you a negative, when they're all multiplied or divided. But then as soon as we get close enough to that first factor, which again would be 3 in this case, well, I guess we're talking about this guy. As soon as we get close to this guy, then that's going to give us a positive value, because this guy will give us negative. This guy will give us something. Okay, there will be a point where, so we're going along. When we get close enough to putting in, so scratch that. We're getting close to where this guy is starting to give us a positive value. This guy right here. So after x is greater than -3, this guy right here, this guy is going to give us a positive value. So then we're just left with 4 negatives, and that's going to give us a positive. So until it hits the next factor, which is what? Which is x minus 2, or x plus 2. After we go after x plus 2, then we have 2 positives. So after we hit x minus 2, so let's zoom in for a second. So as you can see, this is the old graph, which had almost the same factors. But for our graph here, so as as we get down to -2, well, as soon as we get at -2, it's 0, So you have 0 over, you know, whatever that is, something that's not 0. So we get to this, and then after that it's negative for a while, and then as soon as we hit -1, well, this guy turns positive as well. So then we're left with this guy and then this guy right here, all giving us positive values. So we're left with 2. So anyway, you can see how it goes in, how it, you know, again alternates negative, positive, negative, positive. The secret, though, the key is to say, okay, these are the only factors that contribute to asymptotes. So anything in between, and these guys will tell us when to cross the graph. So any of these guys right here, whatever they, you know, whatever you have, well, those guys are going to give us something in between, right? So you have -3, +3. Well, where do those guys hit? Where do those guys equal 0? Well, this one's at 2, or excuse me, well, this one right here is at 2, this one right here is at -1, and this one right here is at -2. So those guys are going to contribute to crossing of the graph, you know, in between our interval, in between this other asymptote here, you know, in between the next asymptote. So that little, you know, this thing is going to go down and up, you know, it's going to cross the graph 3 times before it goes to the next asymptote. So that's kind of what I wanted to explain. That was kind of a key factor. If that didn't make sense, please, you know, put something on the posting. This is my first time actually doing one of these videos, so if I have to do it again or something, I will. But hopefully it made sense, and I'm trying to figure out how to edit this thing. So anyway, thank you for watching, and have a nice day.